Alright, today's problem. Two objects with masses 4 kilograms and 2 kilograms, with mass 1 having 6 meters per second and mass 2 having 3 meters per second, negative 3 meters per second, collide elastically, which means that their energy and their momentum is conserved once they collide. Object 1 stops after the collision. Find the final velocity of object 2, the kinetic energy, and impulses values after the collision. Alright, so let's just draw a diagram real quick. Here we have object 1, 4 kilograms, moving at 6 meters per second to the right. We have object 2, 2 kilograms, moving at negative 3 meters to the left. And the reason it's negative is because it's just going to the left. We're trying to find the final velocity of object 2. We have to recognize that this collision is completely elastic, which means that momentum is conserved following this law, that the sum of all initial momentum equals the sum of all final momentum, which when written out is going to be like this. So if we have the masses and we have 3 momentum values, we can just simply solve using algebra for the fourth momentum value. We know the equation for momentum is P equals mv, so we can just expand this. That's mv right there, mv, mv, and that's mv. To solve for the second velocity, we just have to plug in some values. So the mass of object 1 is 4, the initial velocity is 6, plus the mass of object 2 is 2, the velocity is negative 3, the mass stays the same, and since it stops after collision, which means it has 0 velocity, plus the mass of object 2, which is 2, and then the velocity value that we don't know. So since all these variables are numbers here, we can just plug it into a calculator, and we're gonna get 18, and the unit for momentum is kilogram meters per second equals, this is going to be 0, so that just cancels out, and we have 2 times our final velocity of the object 2. Divide both sides by 2, and we would get a final velocity value of 9 meters per second for the velocity of object 2. Now the question is asking us to find the kinetic energy of the final collisions, okay? So for object 1, it's just going to be 0 because it stops, which means it has no velocity, which means it has no kinetic energy. But for object 2, we have to write out the equation, mv squared, and so 1/2 of the mass stays the same. The velocity value we just got, which is 9 squared, and we're going to get a value of 81 joules. Finally now, the question is asking us to find the impulses after the collision. So impulse is just change in momentum, which is described as J equals change in momentum, or J equals m times change in v. Impulse for object 1 is going to be 4, that's the mass, times the final velocity of object 1, which is 0, minus the initial velocity, which is 6. So we're going to get an impulse value of negative 24. Moving on here to object 2, it has a constant mass of 2, it has a final velocity of 9, we have to minus 3 here, and we're going to get J equals 24. So let's test this out. So here we have our exact setup from before. Our object 1 is the red box right here, our object 2 is the blue box right here, and we're trying to find out the final velocity of the blue box. So let's just run the simulation and see what happens. Okay, so as you can see, the final velocity of the blue box is 9 meters per second, the final kinetic energy is 81 joules as predicted, and the change in momentum or the impulse is 24 here, and the change in momentum or the impulse is also negative 24 here as we predicted. And yeah, that's the video. Thank you for watching.